Okay, so maybe come this up a little closer. So the code is really compact and it's hard to read. I'm not going to get too much into it. I took it right from Stephen Wolfram's blog. So first thing he did is made some tables of the numbers, which I'm not sure how easy it is to understand this, but the patterns are going to be clear in a minute. A black square represented a 1, and a white square represents a 0. So you see this is multiplying by 4. And so we got an interesting pattern going down. But come down here for a second, and I'll show you what we were seeing with our numbers. So when we multiplied by 1 and added 1, remember we saw 1, 2, 2, 2, 2, 2, 2, 2?
Yep.
Mm-hmm. Okay, when I multiplied by 2, do you remember what we saw when we multiplied by 2?
We saw the 1, 1, 1, 1, 1.
Okay, and so what were the numbers in base 10?
1, 3, 7, 15.
Yeah, there we go, 1, 3, 7, 15. And we see, here are the digits we saw in binary. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. When we multiplied by 3, what happened? What did we...
So 1...
1, 1, 0. 1, 0, or 1, 1, 0, 0, 1, 0, 0. So 1, 4, 4, 4, 4, 4.
Okay, so we saw 1, 4, 4, 4. So good news is we were doing our calculations right. Now here we see that and that's why the graphs with 1 and multiplying by 3 are so thin, because the numbers never change.
Yep.
What it's representing here are the numbers. So this would be, at the top would be 1, 1, then 2 1s and 3 1s, and you see how it forms a triangle?
Mm-hmm.
Yeah.
So the same thing's happening with 4, except we have 1s and 0s. So let's look at the first 10 numbers with 4. So we get 1, 5, 13, 45, 109, 365. So it goes 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1. And so here, for the first time, although the pattern, it looks like there's some patterns in the 1s and 0s, right? From this graph. There's not an obvious pattern in the numbers, right? 1, 5, 13, 45, 109. I wonder what that pattern is. But this is kind of what Stephen Wolfram was. Is this still on camera?
Yeah.
Okay. So here's the patterns in the 1s and 0s. So there's something going on here. Pretty neat, right?
Yep.
Yeah.
So let me shrink this back down. And I'm going to, instead of just doing from 1 to 4, I'm going to go from 1 to 20. Okay?
Yep.
This is getting kind of interesting.
Yeah, and
Especially
I probably...
like 19.
Hold on 1 second. Let me squeeze them in so they're on camera. Are they on camera now?
Yep.
Okay. So here's 2. 3, not interesting. 4, we saw a little bit of pattern. 5 looks like a similar pattern. 6 and 7 look actually like they go back to the sort of case with 1 and 3, not much going on. 8 looks like 4. What do you see on 9
It's
here?
like static
It's
near the edge.
It's actually a pattern. It's just a random pattern it's repeated.
Yeah, and what's going on the edges here with these digits?
That's a repeated pattern.
Yeah.
Oh, it is?
Yeah.
Okay.
Something to point with.
That's alright, just point with your finger.
So it's you have this low dot.
Uh-huh.
This you have the low dot. This dot right above it, and then these 3 dots in a triangle.
Okay.
You keep having that.
Alright, so now I'm gonna put 9 back to normal size.
10 is not.
10 is not much. 11 kind of looks like 4 and 5 and 8.
Yeah.
12.
No.
And then 13.
is kind of like a staticky triangle.
So they were very surprised
It's just completely random.
There's just that I don't.
when they
see
discovered
anything.
13.
It's completely random on one part.
There's
and
there's an actual line
there's a
sort of dividing.
pattern.
Yeah. So what do you think's going on here? Like, do you see any pattern in these dots at all?
No.
Over here?
Nope.
Nothing.
Hmm.
And what's going on over here?
It's just
It's
a
totally
pattern.
regular. You've got
Totally
a
regular.
repeating pattern. There's actually like a line going
Yeah.
down.
There's actually a line going down in the binary digits. Craziness, total simplicity.
Yep.
And they just discovered this last night. Or, sorry, last week probably. What do you think about that?
Cool.
And just from playing around. And I mean, I really do think this is the first time anyone's ever kind of looked at this, so I'm not sure anybody knows what's going on here. Like anyone in the whole world knows what's going on here. Do you have an idea? Do you know?
no.
No.
No? Okay. 14.
regular.
Sort of looks like 9.
Yeah. Oh, you're right. There's a little structure kind of at the top, but you're right. 15, and then 16. Now,
It's
wait
back-
a minute. What's 17? What's going on with
Looks like
17?
13 again.
But is it like? It's not.
It's
It's not the exact same,
It's not the
and it's not
this-
really a triangle.
the hypotenuse is there's kind of a jump here. It's
Oh.
not completely flat.
But you still have the same sort of thing.
Yeah,
But it's a different regular pattern
Okay.
and different chaos stuff.
13 was the 13 hypotenuse was completely flat, and this is not.
Ah, okay. So maybe there's some differences in the hypotenuse. Maybe this isn't really a triangle, but it definitely has crazy part, not so crazy
It's
part.
kind of deforming.
And then we go up to 19, and we see the same sort of thing.
The hypotenuse is still regular.
But
Oh.
the craziness is actually more here.
What do you mean?
Like there's in 17 there's sort of there's more craziness in 19.
Okay.
Either that or the triangle is just bigger.
Interesting. All right. So what do you think? So they were trying to figure out. Stephen Wolfram mentions in his blog they were trying to figure out if there was anything going on with 13, 17, and 19. Do you see any pattern with 13, 17, and 19?
No,
No.
nothing.
Okay. Do you think there are numbers above 20 that go crazy?
Probably. I mean, we saw 3.
So should we go from like 21 to 30?
Sure.
Okay. So let's see.
So
1 is crazy.
21 is crazy. And what's different about 21 as a number compared to 13, 17, and 19?
well, it's not prime.
It's not prime. So maybe it had something to do with a prime. Made it
But
crazy. Nope.
And 22, 25, 26, 20, and 27 and 30 also debunk that.
Yeah. What's interesting about 25? What's different about 25 compared to the other numbers?
It's a square.
It's a square. So it's not necessarily prime. But maybe it's only times 2 primes, or no, it's a square. Who knows? This is pretty neat.
Mm-hmm.
And like I was saying, this is something that people studied for the first time just the other day. It really shows the power too of how a computer can really help you.
Also, look at 30.
Okay.
There, I think.
Hold on, I'm gonna bring it up and then over.
I think it looked a little darker than like
There's 30.
from the. I think there might be more black than white because it looked darker than the previous, like 13 and 17. It looked darker for the,
Oh, you think maybe there's more black over here?
yeah, in there.
Huh. Well, we'd have to check. I mean, we could probably write a program that counted in the crazy part the black dots versus the white dots and see if we look for patterns there. There's lots of different things we could explore.
Yeah,
What do you guys think of this?
Cool.
it's pretty neat.
Yeah, it's real fun. All right, guys, good job.